Hello everyone. Today we are going to discuss about state space representation using canonical variables. So last class we have discussed about state space representation using phase variables. First already we have discussed about using physical variables. Second we have taken using phase variables, and this is the third one, state space representation using canonical variables. In this also have different form, that is a diagonal canonical form and also Jordan canonical form. Now first we will take about diagonal canonical form. Let us consider the denominator polynomial involves only distinct roots. That means this polynomial can be separated into different factors. I can say here. This is the rationalized function. Okay, numerator polynomial by denominator polynomial. So this denominator polynomial can be equal. You can say here n times s plus p1 into s plus p2 into and so on s plus pn. That means we have segregated into number of rows, number of factors. Easily we can segregate this. If that means if this polynomial is having different roots or distinct roots, at that time first whatever the factor you have, just see here, this is the s power n and this one denominator also s power n. First you have to simple differentiation, you can say simple division you have to take. That one it is will get constant term, so b0 plus whatever the terms remaining get here, what you will get, some constant, you can say the c1 or c2 whatever it is, into s power n minus 1 next term. Next what we will get, because already we are taking this one, we are dividing with this factor, right? So that's the reason what we are taking, that is equivalent to b0 plus first factor. So some coefficient, you can say here it is called generally residues, right? c1 by s plus p1 plus second one c2 by s plus p2 and so on plus cn by s plus pn. That means here these are the different rows. You can see here different rows where c1, c2 and so on cn, these are the residues corresponding to the poles or roots. Here you can say p1, p2 and so on pn. That's why it is called pi. Okay, where I equal to 1 to. Okay, then this one y by u or y of s by u of s. Just to separate individual terms. Let us take first one. What you will get here? Y of s by u of s equal to b0. First term, second, third, fourth, and so on like that. Separate all the terms. Easily you can calculate. First, let us take here y of s equal to b0 into u of s. Just it is a cross multiplication, right? Just to cross multiply by u equal to that one, y equal to, so that term into u of s, right? First, now we are taking just the first term, keep it same, and second one onwards you take it as this is x1 term and this is x2, x1 of s, x2 of s and so on, xn of s. First one, x1 of s equal to c1 by, this is also residue, right? We are not taking that part, that we are keeping just 1 over s plus p1 into u of s. Therefore, u of s equal to what? S plus p1 into x1 of s, right? So s into x1 of s equal to minus p1 into x1 of s, because you are shifting to the right? So this one just cross multiply here. What you will get here? S into x1 of s plus p1 into x1 of s equal to u of s. Just we want only differential term, first order differential terms only. That's why we are keeping only s into x1. We are keeping left side, remaining term we are keeping on right hand side. So s into x1 of s equal to minus p1 into x1 of s plus u1 of u of s. Similar way for all the terms x2 of s, this one we can find same way s into x2 of s equal to minus 2 into x2 of s plus v of s, right? And last one if you are taking here, so what you will get, s into xn of s equal to minus pn into xn of s plus u of s, right? Now, so what is s into x1 is nothing but x1 dot, that is a differential, right? First order differential equation. So x1 dot equal to minus p1 into x1 plus u, x2 dot equal to minus p2 x2 plus u, and so on. Xn dot equal to minus pn xn plus u. The same, only simplifying in this way. Okay. Similarly, now what is output here? Y of s equal to b naught into u, right? Or b naught into u of s plus c1. What is this term? So that one only, right? So that is x1 of s plus c2 into x2 of s, and so on, cn into xn of s. Substituting these values only this, right? Now y is equal to what? Okay, y equal to, so c1 x1 c plus c2 x2 and so on, cn xn plus b naught into u. Just we are taking state vector side, those are left side, and remaining you are keeping right side in the same expression only, right? This one. Now these expressions, this one, that is a differential values x1 dot, x2 dot, x3 dot, and so on, and output expression. These expressions are representing in state vector form, or you can say we are representing in state model for the diagonal canonical form. Okay, just you see here x1 dot equal to minus p1 x1 plus u. There is no other term x2, x3 and so on, xn. All terms are, all coefficients are 0 here, right? So minus, just you see here x1 dot equal to minus p1 into x1 plus remaining all are zeros, 0 into x2 plus 0 into x3 and so on, 0 into x1, right? Plus 1 into u. That is your first expression from here. Similarly second and last also same, xn dot equal to 0 into x1 plus 0 into x2 and so on, 0 into xn minus 1, right? Plus minus pn into xn plus 1 into u. This is the final expression. So this is the state model for the diagonal canonical form. State equation from this expression we can. What is the output expression? So output equation from this only. What is the y here? Y equal to, again writing in matrix form, c1, c2, c3 and so on, c1, c2 into x. This is the state vector, x consisting of x1, x2 and so on, xn. If you are multiplying, what you will get? c1 x1 plus c2 x2 plus and so on, cn xn, right? Plus b naught into u. Okay, this is the model, state model for the diagonal canonical form. Same thing here showing in the black diagram. So that is black diagram for canonical state model. This is the output y, input is u, right? So now here what you are getting, just you see here output, it is a summation of all, right? So c1 into x1, that is actual first one, right? Plus c2 x2 and so on, cn xn plus b naught into u. That is our expression. What is x1 here? You will get here x1 dot, right? x1 dot equal to minus p1 x1. Okay, so plus u. This is the expression. If you see here, this same thing only. So in this way, we have to represent the state model in black diagram. Okay, this is the state model or state space representation by using diagonal canonical form. Okay, so in the next video I'll explain state space representation by using another canonical form. So that is a Jordan canonical form. Okay, thank you.